Excellent, excellent, excellent. We are live. Hello. Welcome in, you do it. I trust you are well. As you can tell, we have had We've had one or two technical glitches this evening. I think I need to do a little bit of experimentation with my YouTube setup for live streaming. But hey, it is what it is. So, let's start it all again. Just gonna go and fix something here. One moment. I'll fix it again. It's working now. Awesome. Awesome. Well, these are the teething problems that you have when you transition from one streaming platform to another. Good evening, my name is Steve and this is the IQ Workshop, and this is the place that I come to try and get smarter and demonstrate my successes and failures for all to see so that you guys can learn along with me. I've had a few technical challenges this evening, as some of you may have already spotted. And I am transitioning my Wednesday live stream from Twitch to YouTube. And this is the first in a series of live streams that will take place every Wednesday, 8 p.m. until 10 p.m. UK time, which is currently UTC +1, which I have dubbed Workshop Wednesdays. Workshop Wednesdays is going to be where I take a look at a given workflow or a given piece of software that makers will use to achieve a specific outcome or goal. And I am distracted by the fact that I've got something flashing on my screen that shouldn't be there. Hey Carol, welcome into stream. How you doing? Yes, teething problems. Teething problems. I will get there. If you ain't failing, you ain't trying. So tonight, I am going through a beginner's guide to Fusion 360, from where do you get the software, how do you download the software, the different licenses that you have available to you, what feature sets those licenses give you, and look at the overall interface and hopefully get people up and running as quickly and easily as possible. A good friend of mine reached out to me and asked for this specific yeah, right, Squirrel? Specifically asked for this content to be covered. So I am more than happy to take viewer requests. If there is some areas of stuff that you want to pick up on that's within my wheelhouse to talk about, I will absolutely go through that. I definitely will not go through something that I don't know about, or I'm not gonna kind of blag it and make out I know stuff when I don't, because simply that just exposes you. So as I say, this is all about Fusion 360. Fusion 360, for those of you who don't know, is a CAM piece of software. CAD meaning computer aided design, CAM meaning computer aided manufacturing piece of software, and essentially it allows you to create a 3D representation of an object, allowing you then to take it into various different manufacturing processes. Those processes can be things like 3D printing, laser cutting, CNC, just to name three. Those three workflows are essentially my trifecta. They are the three workflows that I've always wanted to have at my disposal so that I can make pretty much anything that I want. But they have always seemed to be out of reach. And over the years that I've been a maker, I have slowly but consistently and incrementally improved my tool chain to the point where I am on the cusp. I'm on the cusp of completing my trifecta. Hey, CE Waffles, how are you? Welcome into stream. We could probably do a short for that, right? That's something we could probably do. Although it might have to be on my CR10 V1 3D printer because the motors and the motor drivers on that printer are quite loud. I've got two CR10 V2s and they got the TMC quiet drivers. So good evening, James. How are you? Welcome in. Welcome in. So as I say, this is all about Fusion 360. I want to give a little bit of background. If you go through the content on my channel, you will see some videos about a piece of software called FreeCAD. FreeCAD is an open source version of a CAD CAM piece of software. It's something that I covered back in, I believe it was September, because there was a change to Autodesk's licensing agreement, and a lot of makers in the community were somewhat upset about the changes that were being made and were looking for alternative pieces of software. The most logical choice was FreeCAD because it offered a similar feature set and on the surface looked to be of similar a user interface. While that is true, there is a learning curve to FreeCAD, and the video that I produced is a genuine representation of somebody going into FreeCAD completely cold. So if you're a Fusion 360 user, you could get into FreeCAD. This is the sort of experience that you're likely to this is the experience you're likely to have. This is the learning curve you're going to have. So Fusion 360 remains to this day to be my daily driver, as I stated in the closing notes of that video, simply because it meets the requirements of my workflow. If Fusion 360 doesn't meet your requirements, then it isn't the software for you. And I'm not going to promote a piece of software if it doesn't fit your needs. I'm all about sharing the knowledge and trying to share things with people so that you can get the most out of these things and achieve your goals and objectives from a maker standpoint. Thank you, James. I appreciate that feedback. So, as I say, Fusion 360 will drive the three workflows that I'm interested in. Tonight, we're going to focus specifically on 3D printing. And let's dive into it. We've already been delayed by some technical challenges, so let's get on. So Fusion 360 is available from Autodesk.com or Autodesk.co.uk. It's you can download it. You can download the free trial and give it a go and see whether you like it. You can do the subscribe piece. Now, as I said, there are 3 different licenses that are available for Fusion. The first of which is the subscription model. The subscription model for me in the UK is £438 per year. And some people might say, "Oh, that's a bit steep. That's mucho moolah." But when you consider this is a professional grade manufacturing piece of software that is used in manufacturing houses across the world. It is used to design. Well, we appear to have what appears to be a two-stroke engine for a motorbike, perhaps, on screen. You have the ability to create these models that then go on to these advanced manufacturing techniques and be made as a genuine product that goes to sale. If you're using 360 for manufacturing, then £438 a year isn't a significant amount of money from a business perspective. From a home user perspective, that is a chunk of change. Especially if you don't have it. So that's the first license. The second license is the educational license. Now, the educational license is intended for somebody who is in school, university, technical college, who is learning fabrication, etc. Now, you can, if you qualify, you can apply for the educational license, and you get a full feature set of Fusion 360, exactly the same as the paid-for subscription. The final license is what's known as the hobbyist license. Back in the day, back in 2020, and it's now known as the personal license. For the most part, it is the same as the previous two licenses. However, there are some challenges or differences. The first of which is the number of consecutive files that you can have in an editable state. The second is the types of files that you can actually export and get out of Fusion 360. And thirdly, the main difference is that 5-axis CNC controls don't work in this version. They're not available. Now, for me, I can export STL files for my 3D models. I can export my DXFs for my laser cutting. And I will be able to export G-code for my 3-axis CNC. So for right now, Fusion 360 does tick all the boxes. And it's served me well over the years, and I've invested quite a bit of time learning this workflow. One piece of software doing them all, if you like. So I'm not overly bummed by the changes, and I understand why Autodesk have done it. They are a commercial entity. They are there to make money. It is a capitalist world that we live in, and ultimately, if Autodesk loses money or doesn't make enough money and goes out of business, then Fusion 360 is going to disappear completely. So I get it. I do understand. Autodesk did a really bad job of communicating this at the beginning. So hopefully the dust has now settled. Everybody has now seen what Fusion 360 is going to provide them in the post change world. And that's that. So as I say, autodesk.co.uk, if I can put my teeth back in, autodesk.co.uk or autodesk.com for the download and installation and registration of your software. So once you've downloaded it, installed it, you will be presented with your user interface of Fusion 360. Frank Grimm, welcome in. How you doing? Good to see you, buddy. Yes, indeed I am. I am going to show you how to use this software. This is a beginner's tutorial on Fusion 360. It is not going to be going into the hyper detail. This is the intention of getting somebody who's never used Fusion 360 before up and running to produce some basic objects, export them, and get them ready for 3D printing. So, let's quickly go through the user interface of Fusion. and we'll get right into it, right? Because there's a ton of stuff that we can cover in here. But what I'd like you to do, I would like you to, if you've got any questions as we go along, please feel free to yell those questions out. In fact, I think I might fix my yeah, I'm gonna fix my chat options. Give me 1 second. See if I can fix this. Yeah, there we go. That's better. I can bring you onto stream now. Awesome. You go ahead, buddy. You fire up the PC and we'll get into this. So, first of all, you've got the data panel on the left-hand side. By clicking the data panel, you get to see all of your options here, right? So this is where all your projects are. And what we're going to do, what we got in here, just going to quickly just set this up so you guys can see it from the very beginning. Let's archive that out. Okay, so this is where we have all of our files. Whatever you want to find, like past work that you've done, it's all in here. Now, this is my recommendation. The first thing you do when you're starting a project, click this new project option up at the top, and then we just type in a name for that project that represents the work that we're going to be doing in the software. Because this is a YouTube tutorial, we're going to just call this YouTube 101. Okay, hit return, and you'll notice that folder will now jump into the list of folders that we've got here based upon alphabetical order. You can pin a particular project, and by pinning it, it goes directly to the top, just like that. So the next thing that we want to do is double click that folder. And we go into this folder, and this is very much like Mac OS or Windows or Linux, excuse me, where we have a folder structure. So we could create more folders for a really complicated project, or we can just save things just here, which is what we're going to do for tonight's video. Now, that brings me up to this set of controls here, right? So we've got file options and we've got save. So we're going to save this file right out the gates so we don't lose our progress. And we'll call this basic shapes. Okay, so now I can demonstrate the first piece that we were talking about in terms of the limitations of the personal license of Fusion 360. And that is the option over here, right? You can see now that I've got 6 projects open of 10. If I go back into my data panel, you can see that we've got an option here to make this editable. And if I change it, I can make it read-only. Now, once you've finished the file, that doesn't mean to say you can't import it into another project. So that's one of the ways that you can toggle the items from being editable to read-only. We're going to keep it on editable because we want to make some shapes in here in a moment. Okay, so as I mentioned, there is a bunch of options in terms of workflow that this offers you. So we've got a solid workflow, which essentially you can create some quite complex geometries that we're going to be saving out to 3D printing, or we might create an assembly that we're going to send to a laser cutter, or we might create a device like the jaws for a pillar drill clamp. And we might send that out to a CNC. So we'll probably do the majority of that work in the solid section. The surface section, just up here, that gives you a workflow for mesh modeling, if you like. Now, this is primitive in terms of what it's capable of doing. Fusion 360 is really good at doing like static objects. So things like a chair, a table, a car, things that have been previously manufactured. What Fusion 360 doesn't do a great job of is organics. So if you wanted to model a tree in Fusion 360, I'm not going to be as so bold as to say you can't do it, but I would probably say it would be somewhat challenging. You're probably better off using something along the lines of Blender, Maya, 3D Studio Max, a piece of art modeling software that would be better suited to create that object. The last one we're going to take a quick look at is the sheet metal. So the sheet metal workflow allows you to make enclosures. So if you wanted to make an enclosure for an electrical control box, and you're going to make this out of, I don't know, 2mm steel, you can absolutely create the bends and all of the geometry for a sheet metal job, and then actually export it as a flat object that you can then take to a plasma cutter or take to a fabrication house that can go off and actually create that enclosure for you. So as you can see, this is quite a powerful tool with a bunch of options that are available to you. So as I say, let's stay in the solid section. In the solid section, predominantly, we are looking at a sketch-based piece of a sketch-based modeling. Stumbling over my words. And we can create sketches on any of the three 3D planes, X, Y, Z, and we can create simple, primitive objects, but we can also do some complex things. To start off real simple, we're going to go ahead and we're going to just create a simple cube. It's boring. I know. It's not like you're creating a Ferrari race car or anything like that, but we got to start somewhere. So to start the sketch, you click on the sketch icon up here, just under the word solid. And by doing so, it prompts you to select one of the three axes to start drawing on. So let's go ahead and click one of those. Yeah, do you know what, you do it? That is got to be one heck of a challenge to do that. They are far more capable in here than I am. Hey, Print Play, welcome in, welcome in. Yes, I had some technical challenges with the stream. I suppose it is the growing pains of starting to stream on a new platform and just trying to iron out the technicalities of that. So you're all good. You're all good. Thank you for showing up. Appreciate you, buddy. So we're now in the sketch tool within Fusion 360. And you can see that we've got a gradient system that tells us these squares are representative of a certain measurement size. I'm currently configured in millimeters, but we'll just see in a minute. Fusion 360 is pretty smart in what it can do. So using my middle mouse wheel, I can scroll in and out. If I click the middle mouse button and hold it, I can pan left and right and up and down. And the last sort of navigation, if I press the shift key and press the middle mouse button, I can actually orbit around a particular object. And you'll notice in the top, right corner, we've got a cube that represents the front, sides, top, bottom faces. You can see that that's actually rotating real time as we rotate around an object. And that works in all of the views, right? So that's just basic viewport navigation. We can now use the cube to reset the view by just clicking the top of the cube to snap us back to the top, and we can go from there. Now, there's a couple of different ways that we can create our cube. The first is to draw a set of lines. So if I press L on my keyboard, that is the shortcut for line. And you'll notice that my cursor now gets this sort of vectorized little logo on it. And that indicates that we're in the line tool. So if I click on the origin of the drawing, and we'll go up some amount. Let's go just there. We'll come across, we'll click there, and then we'll come down. And then we'll come back to the origin point. And by clicking the origin point, the vector of this rectangle has now been closed. And I know it's been closed because the center of, or the inside of this has now actually turned a light blue. And that's a nice little visual cue that the vector loop is closed. Now, what if we want this to be a certain size? Well, we can actually do dimensioning of these lines. So by hitting the D key on your keyboard, you get like these two arrows on your mouse cursor. And we can select a line and specify a dimension. So let's say I want this to be 25 millimeters. So I hit 25, hit return. Let's make it a square, right? So let's go dimension this side wall and call this 25 millimeters also in the dialog box. And we now have what's called a fully defined sketch. Now I know it's fully defined because you'll notice that the lines have changed from a light blue to a bold black line. And that defines, that tells us a visual cue that the drawing is fully defined. The Reddit post is continue to fill up your phone. Dude, that's awesome. I love it. James, we definitely gotta meet up IRL. Yeah? We gotta have a beer sometime. Yes. Yes. I get that you do it. Absolutely. Dimensioning your sketches is tedious. It is good practice to get these, under control. But yeah, it can be a bit of a challenge to get your head around it sometimes. And sometimes if you've got a lot of facets to a drawing, we're only looking at very simple drawings right now, but anything to do with complicated stuff, that can sometimes be a bit of a mind blown moment. So we're going to finish the sketch, and we now have a square in the viewport. Now we want to turn this square into a cube. So let's go ahead and click the extrude button, which is the second icon along, and it's automatically selected the geometry. Yeah, the inside of the square that we want. But if I deselect that, essentially all you would do is just click on the geometry that you want to extrude, and that would be good to go. So what we're going to do here now is we got two choices. We can either enter in this box here an amount that we want to extrude by. We can put in this portal the distance. This box is the same thing, right? It's just brought it over to us, so we haven't got to stretch our mouse across to this control panel. Or we can click the arrow and just drag it vertically up. Now we're going to call this, we're going to say this is 25 millimeters. Okay, so we're making it a cube. Like so. And we now have our first 3D object in the viewport. Now, while we've been working, Fusion 360 has been following us along the journey. We actually have a timeline. Now, down in the timeline are all of the operations that we have placed or done within Fusion 360. Fusion 360 is what's known as a parametric modeling environment, meaning that we can do some complicated math work inside of Fusion and formulas and stuff that we can change at a later date, and it will completely recompile the object to whatever it is we want. So the big thing to note here is the notifications that you can sometimes get in the timeline itself. Those things are one, a yellow panel. If an object on the timeline has turned yellow or has been bolded yellow, it means that it has an error within it. It's an error that it can recover from through guesstimation. It may mean that something might be a bit off. More often than not, it'll be okay. But ideally, you don't want a yellow icon. If, however, the icon is red, that means that it is broken and it cannot progress through the timeline thereafter. So what we're going to do, we're going to go back and we're actually going to edit something retrospectively. So now we've got this cube and I say to myself, actually, I think my measurements are a little bit off. I want to correct these measurements. So what I can do is come down here in the timeline and I can right click the object of the sketch and then click edit the sketch and we roll back in the timeline. Now I mentioned earlier that Fusion is pretty clever in terms of its measurement system. If I double click this dimension line, it turns it into something that I can edit. Now, let's say I want to make this 2 inches, right? I got 2 choices, right? I could say, do you know what? 2 inches is 50 millimeters. Type in 50 millimeters and away to go. Or I can type in 2 INC for inch, 2 IN, correction, hit return, and it corrects. It knows that 2 inches is 50.8 mil. Which is really clever. So now we have an object with some different dimensions. So what I'm going to do now is we're gonna add some additional things to this sketch. I say sketch, this object. So let's say for example we want to make a block that will take two bolts. Yeah, we want to thread some bolts in here. So what we can do is we go back into our sketch mode and we'll click on the top surface here. And what we can do is we can create some circles that will allow us to form the hole itself. So let's say we're going to use some 8mm bolts. So I'm going to say C for circle. I'm going to just put a circle in there and just say 8 millimeters. Circle 8 millimeters. Oh, let's try 8. Now you'll notice that these holes are not centered, and they're not uniformly dimensioned throughout the object, which is absolutely fine. This is a quick and dirty way of getting your sketches into a usable state. Yes, James, there is another James in here. Yes. So, print and play is also James. So what I'm going to do, I'm going to dimension one. We're going to leave the other one off axis. And then we're going to come back and edit it and correct it just to show the power of the editing nature of this software. So first things first, we said that this line here was 25 mil if I remember correctly. So if I click on dimension and I click this line here, I can now dimension the center of the circle to the edge of an object. So if we say 25 mil, that's going to stick the circle at the top. Now you can either do the math in your head, or you can do 25 divided by 2, hit return, and it sticks it in the center. And again, we know we want this to be 1 inch, because this is 2 inches long. We want this to be 1 inch off the side. So let's dimension this from the wall, and we'll say 1 IN. Okay, so that is now in the dead center. So let's say 0.5 IN. Okay. The other circle we're going to leave alone. We're going to leave it alone, and we are going to correct it in a moment. So we'll finish the sketch, and we're now going to use the extrude tool again, and we're going to select the geometry that we're interested in using. So these two circles, we are going to turn into holes. Now, there's a couple of ways that we can do this. We could, as I say, we could either type the number in. We can grab the handle and drag it all the way down. And you'll notice that this has now turned red, right? The hole will go all the way through, and we've now got holes. Yeah, because it automatically changed that operation into a cut. Okay. Now, if that wasn't what you're intending to do, you can change that. You can say join, you can intersect, you can create new bodies. There's all sorts of operations that you can apply to this. Now, there is a fundamental problem with the use case that we've got here. We're trying to punch a hole through an object. So let's say we go 25 mil. Oh, we want to go 25 mil in the negative. And we've got these perfectly framed holes. But wait 1 second. We've got a problem. We've got a problem in that the height of the cube, or this object, is too small. So we'll go back to this operation and we'll edit the feature, and we'll say it needs to be 30 mil. Darn it, I should have measured twice and cut once. Right? And we've done that, but there's a problem. The hole doesn't go all the way through. So what's the deal here? Well, if we look at our operation for the cut, we can see that we only went 25 mil through the object and not all the way through, since we've changed this. So there's two ways to remedy this. The first of which is to grab the handle and strike it all the way through the object. But there is a better way. The better way is to, let's get rid of the distance. Let's go 0, right? We've got an extent option here. The extent option is essentially saying, right, do you want to go to distance? Do you want to go to object? Do you want to go to all? So we're going to go to object. And what we can actually do, we can define the distance between two planes that we want the holes to go through. So I'm going to select the bottom face of this rectangle, and you'll notice that the holes are punched through. And if I click on OK, the holes are there. So if I go back, excuse me, if I go back into this edit feature and I say 100 millimeters, 1,000 millimeters, there you go, and hit return, the holes are still there. Right? You still see them on the top and you still see them on the bottom, which is pretty darn cool if you ask me. So let's go back to what we said. We wanted 25 mil. Boom. And there is our holes right now. Oh, darn it. We've got a problem, Houston. You can do a lot of things here. You can reference it. You can create. So can you reference it to a side dimension? So if you alter the side dimension, it will always stay in the middle. So you could do that. You could orientate the object so that it's in the center point of the sketch. There's a number of ways of doing this, and it's all about finding the right way for you. So now if I go to this sketch, right, I want to correct this circle. So I'm going to go back in after the fact, and we're going to dimension this circle to here, and we're going to put in 12.5 from here to here, which is 12.7. We click on finish, and bingo, the holes are now in place. Now, I don't know if any of you have 3D printed threads before, but creating threads in Fusion 360 is insanely easy, right? Let me show you how. So in Fusion 360, we have a series of create tools and modify tools, and we're coming on to the modify tools in a moment. So if I put the create option down, and here's all the different things, right? We're not going to cover all of these things, but one of the things we are going to go for is the thread option, right? So we've now got our thread control panel over here. Let's drag it over. And we're going to select the geometry that we want to apply the threads to. So if I click this cylinder here, the hole, and I click this one also, we now have two holes. And essentially we can now go through here to say, right, what do we got? We got all these different profile threads that are available to us. And we've got various different sizes. So we want an 8mm hole. 8mm thread, and we've got the options of a 1.25, a 1, a 0.8, 0.75. So there's lots of standard thread sizes available to you. Now, if I click on OK at this point, you'll notice something a bit strange. These threads look, well, they look a bit weird. The reason they look weird is because right now they are a texture. It's just an image of a thread. But what we can actually do is turn that into something which we can 3D print and actually use. So by going back into our timeline and right-clicking the feature object, edit the feature, we can choose to have the threads modeled. And as soon as we click the modeled option, watch what happens. Boom. We now have the geometry of the threads cut into the model that we've just created. And it is as simple as that. So I've covered quite a lot since the beginning of stream. Are there any? I'm going to take some questions. Yeah, are there any questions in chat? Gotta love chat delay. So I'll keep going. But if you guys have got any questions, by all means, throw those into chat, and that will we'll go off on a bit of a tangent on a chat-led activity, right? So, okay. So some of the other features that we've got are to modify things. So the most obvious modification tools that we've got are to create chamfers and fillets. So a fillet is to round over an edge, and a chamfer is to create an angle on an edge. And we'll do a demonstration of both of those. So if I select the fillet, we get another control panel here, and all we do is we select the edges that we want to create the fillet on. And again, like we've seen previously, we can drag the arrow, or we can actually specify a radius. So let's put a 2 mil radius in here. Now, if I want to add additional edges to this chamfer operation, this fillet operation, all I got to do is press the control key and select the next edge, and you'll see it's highlighted. Let go and it pops into the rounded edges. And let's go all the way around. So press control, let go, and it pops. I mean, I don't have to let go. I can choose multiples at the same time, like that. Right? Easy peasy. Easy peasy. Now, so filleting edges on a box that's going to get 3D printed like this helps reduce artifacting, because your 3D printer is going to move in the XY plane, and it's going to shoot across to a corner. It's going to try and stop, and then it's going to try and change direction from X to Y or Y to X, depending on the direction of travel. Depending on your 3D printer and how you've got it tuned, what can happen is that it'll create a vibration. That inertia trying to be stopped and then moved creates a visual artifact in the 3D print itself. By filleting the edges, rounding these edges off, the nozzle will actually sweep around that edge as opposed to coming to a dead stop, thus reducing the amount of visual defects that you're likely to have. I haven't experimented to see where there's likely to be a diminishing return in terms of how small that you can make that radius. But ultimately, those radiuses will help the print quality of your object. Let's have a look. We got a question. Can you alter the direction of the thread easily? When you say the thread, what are you referencing? I'm not quite sure I know what you mean by a thread. Can you clarify? So, these are all lies. 3D printing is so easy. So 3D printing, when you've got it set up and you've got it working the way you want, yeah, it is easy. But there is a learning curve, and the time that I've spent over the last 4 or 5 years learning bed leveling, bed adhesion, and all of those sorts of things. Oh my word. So when you get you get peaks and you get troughs. Yeah, it's a bit of a 3D printing is a very addictive hobby, if you want to call it that, to get into. It's so enjoyable that especially Delta printers, they are absolutely mesmerizing to watch when you've got these 3 vertical axes which represent X, Y, and Z all at the same time, and they perform this ballet, this dance that causes the hot end or the end effector to move around the build platform. You could sit and watch it for hours. It's amazing. Yeah. Let's have a look. Oh, right. The reversal of the thread. Do you know what? That is something that I have never ever looked into. So let's see if we can figure that out. Let's see how intuitive this is. So if I go into the thread operation, it's going to be in here. And direction. It's pretty straightforward, right? We go into the direction, drop it down, and we can say left-hand thread, click OK, and it's done. Now, because I did these at the same time, these are going to be a single operation. If you wanted to alter these independently, you would have to create a thread on its own here and a thread over on its own over here, and that would then allow you to be able to manipulate a left and righty thread independently. So bear that in mind if you're going round an object and it has a combination of left and right-handed threads, you have to do them either in batches of lefts and batches of rights, or you have to do them individually, whichever is the most practical for your application. Yeah, exactly. Yeah, Delta print. So Frank, my first 3D printer, I couldn't afford a 3D printer when I first got into the hobby. And I scratch built a Delta printer because I thought that was like a good design to start with a first time build. Anyway, it wasn't a kit, let me tell you. It was a complete scratch build. The journey that I went through on that, oh my. But I can't stress, scratch building a 3D printer isn't for everybody. However, I'm now in the position that I have sufficient knowledge that any motion system, be it a laser cutter, which I've taken in a non-working laser cutter and restored it, 3D printers, which I've built from scratch, and CNC. I'm in the process of restoring a CNC machine, albeit a hobby grade, but I am not intimidated by any machine now. None. It could be a 5-axis, robotic arm, and I understand the fundamentals of how these things work sufficiently enough to know where the dangerous ends of things are. That's pretty much where I start, because like threat to life and limb is always important when I'm the one holding the screwdriver. But yeah, it's all the same. Rinse and repeat. Rinse and repeat. So I lost you on the holes, did I? Okay, well I can show you that fairly quickly, because we have a timeline that we can go back to and take a look at. So let's go back in our timeline. Let's go to the very beginning. And the first thing that we did was we created our sketch. Right? Now, one word of warning. I haven't talked about this at all. So I will do this now. So it's a good opportunity to cover this. Now, we have a browser here. It's almost like a directory tree. And these are all of the elements that make up our object, our assembly, all of that stuff. So we can look in here and our sketch is hidden. When you extrude from a sketch, Fusion 360 thinks you are finished with it and it will hide your sketch immediately. Okay, it's not gone. You've just got to come into your sketches and you've got to switch them back on. Okay, so we did the sketch, and from the sketch we then did an extrude of the object. Let's turn that sketch off so it gets it out of the way. The second thing that we did was to create a sketch on the topmost face of the object that we've just created. Okay, so if I go and edit that, we went in and corrected it, but we defined how far off the one side is, and then we centralized it, and we spaced them equally, etc. So we placed our circles on the body that where we wanted them to represent where we're going to make some holes. So once we did that, we did an extrude. And that extrude operation punched the holes directly through the object. Now, if I just edit that feature, what happened was when we did the extrude, we can grab it and you can see that it instantly turns red. You can see these red cylinders, which is representing the cut job that we're currently doing. Fusion 360, when you try and drag extrude a sketch into a body, it automatically considers that a cut operation and it will change it. You might not want to do that. You might want to create a new body. You might want to intersect. You might want to join. An example of joining is where this is probably a bad use case, but it demonstrates the functionality, right? So we'll pull this down and we'll say we actually want to join. And we now got these two pins that exist. Okay, and that's one body. If I go into the body section, this is just one single body. But as I say, if I right click, we edit the feature, and we'll scroll this back up, and we're going to say we're going to change that to a cut operation. Now, we said 25 mil was the height of our object. Minus 25 is the cut. Minus 25 millimeters. Like so. And that gives us a hole there, right? But if we extrude that, if we go back into the workflow and we change the height of that, those holes don't actually make it through all the way. They become like these little pockets that we've created. So in order to make those holes pass all the way through, what we do is we edit this, we edit the feature, and in the extent section, we change from distance, we change it to object, and we tell it the object that we want it to go to. So if we choose this bottom face, it doesn't matter now if we change the height of the object itself, which I'll demonstrate here. If I go to, I don't know, 50 millimeters. Right, we still got holes top and bottom. We've got it all the way through. Whereas before, if we specifically set a height, then they would have just been closed off pockets. Now that's fine if that's what you're trying to achieve, but here we were trying to achieve having these as being holes. So we'll go back to 25 millimeters. And we'll click the home button, and that'll take us back to a view that's actually a good point. If you get lost in your object, right? So let's say you zoom off the screen, or you drag it and you think, oh, where the heck am I? You can use this orbital section at the top to reorientate yourself. By clicking the home, it'll drag the object back into view. So once we did the holes, we used the create option and we chose threads, and we created threads in the holes themselves. So if I right click the operation, we get the control panel for that feature, and we choose whether it's a left-handed or right-handed thread. We can choose the ISO profile, or we could choose an Acme screw thread, all of that cool stuff. One thing, if you're going to be 3D printing the threads, you need to make sure that you've got the modeled option selected. And once you've got the modeled option selected, you're good to go, right? So if I uncheck that, right, and click OK, you'll notice that the threads look a bit weird. Yeah, it's because it's a texture being applied to the inside of this cylinder. So by going back into that operation, it's not checked by default when you create this. So by checking it, you can actually have those modeled. Now, you may not want the threads to go the full length of the hole. So you can actually choose, you know, whether or not it goes from the top all the way down, or whether or not it goes from another location. Let's see where we go. Offset, full length, size 8mm, right-handed, faces selected. I think perhaps because it was the direction that we chose it, but yeah, you can have. Okay, I see what's going on there. I'm just figuring it out as we speak. So if I choose modeled and choose that, you can scroll down. There we go. So you can actually thread like a certain section. Not that that's very practical, right? But if you wanted to, you could have a thread there in the center. But we're going to choose full length. Click OK. Unmodeled thread looks like a drainage pipe, right? Now, what I can't stress enough is that your 3D printer, when you're making something, you need to allow something called clearances. So clearances is the physical space that you will allow an object to come in contact with another object, for example. So if you imagine a door in a door frame, there is a physical opening that the door can fit into. So you would need to make sure that there is sufficient space, one, for the door to actually fit, and two, for the door to actually operate and open. The second thing that you need to take consideration of is the machines being used and your ability to use those machines. So we're looking at 3D printers and how accurate they are. When you 3D print a 25 by 25 by 25 millimeter cube and you put a set of digital calipers on it, you get to understand what discrepancies there are in the manufacturing system. You will have to allow an element of tolerance for the tool chain that you are intending to use. So that will vary from 3D printer to 3D printer, and you will need to figure out what the tolerances are on your machine. If the tolerances are not acceptable in the 3D print, you have to adjust them in the software. That's option number one. Or the second option is to recalibrate the axes of your 3D printer to try and make them a little bit more accurate. So that's creating a very, very basic shape. Now, we have actually broken one of the fundamental rules of Fusion 360. It's called rule number one. Rule number one in Fusion 360 land is you create components. You'll notice when we go to Fusion, the browser, we've got this basic shapes V1, which has got a little bullet point next to it, just here, right? So this is a master component or an assembly. What we can do is to right click here and create subcomponents if you're making like a sub-assembly. Now, because we've made a very basic object, it's nothing to write home about. I'm happy in breaking rule number one. I'm not going to create a new component just for this little block that I'm creating. But if, however, I'm making something which is a lot more complicated, like a 3D printer, for example, I probably do want to break things out into their individual components. Let's see if I've got an example in my tool chain that shows that. I think I may have everything archived. Ha! Yeah, I've got everything archived. So I can't demonstrate that in... Oh, what about the siren? Okay. So here's a laser cut tray that I modeled. It's actually on the wall behind me, holding all of my IT equipment for... It's holding all of my IT equipment. It's right there, right? It's on my French cleat system. And did I even here, I didn't create. I've got all the bodies in one assembly. So what I should have done, really, I should have created a component for each of these elements of this object. But it hasn't killed me, right? So one of the things that I strive for is to try and keep a simplified timeline. Down here in the timeline, these are all the operations that go into creating this reasonably, this I would consider this an intermediate object based on the thing that we just created in the other drawing. So it does what it needs to, but you need to pick and choose when you break rule number 1. And it's a conscious decision. Do I need components? Don't I need components? And typically, if you're going to make something that you're going to assemble in the computer, then I would definitely recommend using the component route as opposed to just creating stuff in here, because it compartmentalizes your workflow. So if you make a mistake on a particular object, so back in that tray, maybe one of those trays was wrong. In that diagram, I'm going to have to go back in the timeline and try and fix it. Whereas if I have a component, I can go in and I can just literally have a very short and condensed timeline for that component only, and it makes it so much easier that to correct mistakes. Okay, so let's get into some hacks, right? So one of the things that I like to say to people is we need to try and keep a timeline as condensed as possible. Sometimes I get a little bit overzealous with that, in that I try to have everything defined and constrained within a single sketch. That can become a little bit problematic. And that's an internal battle that I've got. But there are things that you can do that will certainly help you in keeping the timeline to a minimum. So, for example, I am going to create a new component. I'm going to hide this body. I'm going to hide these sketches. I'm going to right-click, new component, and let's call this a bell. Let's make a bell, shall we? Okay, so when you think of a bell, you might think that you think of the object geometry. That is kind of complex when you think about it, because it's a thin wall, it has a particular shape to it, and you're going to try and model that in 3D software. How are you going to do that? So one of the ways that I would do it to try and make this as simple as possible is to go into my sketch. We're going to choose one of either the X or the Y plane to draw, and we're gonna build the bell in profile. So imagine we slice the bell in half, and we take a cross-sectional look of the material that the bell is made from. We're looking at creating that shape. So what we're going to do is, first and foremost, we're going to create a construction line. And to do that, we've got two choices. We can either go to the line type control panel and choose construction, or we choose X on the keyboard. And you'll notice by pressing X, you'll see that is toggling, right? You can see it lighting up and going off. So when it's lit up, we're creating a construction line. So if I press L now, like we did before, go to the origin of the drawing, and we're going to go to 75 millimeters. Hit escape, and there's our construction line. Now that construction line can move. I want to fix it in space. So to do that, I'm going to right click it. I'm going to choose fix. And you'll now see that construction line has turned green, indicating it's locked. We have used all manners of super glue and gorilla glue, and we have stuck it virtually to that space. It ain't going anywhere. So now we can kind of look at how we're going to create this bell. So I think we're going to use some circles to create the bell. So let's press C on a keyboard, and I'm just going to roughly put a circle. Oh, wait. We are currently still in construction line mode, so we need to get out of that. So hit escape, press X. The toggle has come off, so now we can go ahead and create a circle. And let's do the bell, the top of the bell, right? So there. So we've got this nice little sweeping circle here. And I want to have another sweeping circle coming in the opposite direction to flare out, as it were. Okay, so let's do that. Let's see, what do we got? Can I tangent the circle? I will go here, and we'll just put the circle side by side. And then what we're going to use some of these constraints. So these constraints we can use to control the line objects, and we want to make this a tangent. So we're going to create that. Click the tangent icon, which is the circle and straight line, and click the two circles, and they become joined. Now that's kind of like not where I want it, so I'm going to move that. And I'm going to do it the old-fashioned way by hitting the M key, move or copy, and I'm going to drag it down. Ooh, and we're noticing that the circle in the center is moving as well, but we don't want that. So let's fix that. So how do we do that? We right-click the circle, and we say fix. And that's not going to go anywhere anymore. We're going to click the circle, and we're going to drag that down, and you'll notice it will follow. It follows the contour of the primary circle. So we're going to get it down to this position. Okay. And now I'm going to create a line from the center. Let's click OK. To here. And you'll see why I'm going to do that. I'm going to start trimming. So if I click T on my keyboard, I get like a pair of scissors on my cursor. And I could just click away, and we'll reveal this new shape, right? So the next thing I want to do is I want to create an offset of this. So if I press the O key to create offset, right? So we've now got this line here. And I hit return. And we've got a 1 mil sort of parallel line offset from the original. Now you'll notice that this isn't closed because the inside of those lines is not blue. So we got to close this up. So to do that, we're going to create the circle. And again, we've got different types of circles that we can use. We got a center circle. So we actually define the center point of the circle and we dimension it that way. Or we can have a 2-point circle, a 3-point circle, tangents, 2 tangents, and a diameter. There's a lot of flexibility in here. We're going to choose a 2-point circle. So we're going to come in here and we're going to select that vertice or the little dot, and then we're going to go to the other little dot like so, right? And we're going to do that at the other end of the line like so. And you'll now see that the inside of this profile has turned blue. So if I now trim it, okay, and I just realized I've made an error, so I'm going to go back and correct it. So I'm going to escape a moment, and I'm going to go Control Z, Control Z. I actually want a line like that. Okay. So the next thing I want to do is come in here and trim this line because I want the extrude to be as simple as possible. Now we've got to have like a little boss for the handle to attach to. And we can do that simply using the line tool, going from the top of this here, coming up by, let's say, 3 mil. And then clicking, coming across by 3 mil. And then coming down to that object. And we're going to trim that section out there. Oh, no, we're not, because as we trimmed it, we lost the geometry of that line. So let's put that back in place. Leave that as it is. And when we finish our sketch, we see we've got this weird sort of bell shape, yeah, that is orientated around this center line, if you like. So here's the magic, right? Here's the magic. If I go in here to create, and I create a revolve, what I do is I select the profile that I'm interested in revolving, which is the profile of the bell and the boss itself. And then I choose an axis that I want to revolve this around. I've now, albeit exaggerated, I've got a bell. Now I can choose like only go to a certain amount. Yeah, but I'm going to go 360 degrees, click OK. So that kind of looks a little bit silly, right? So let's fix it. I could, yes. Absolutely, I could. So, in fact, James, we'll fix that. Right, so if I go edit the sketch. So first things first, I'm going to put my circle, 2-point circle from there to there. And I'm going to trim out these items. I'm going to simplify this somewhat, right? So that's done there. You mentioned a hoop. So what we can do is we can do a 2-point circle at the top. I'm going to get to show off another feature in a second. So we can go here, bring it down. Let's say we want a 3 mil hoop. Right. And we'll click it there. We'll trim it. And we'll create a line just here. probably have a line there. Yeah, that'll do us. Okay, so now when I finish, the bell looks a little bit better, but you'll notice we don't have the hoop. So we got to go in here, edit the feature, right? And then we got to make sure that we choose this section in here, click OK. And then we've got that little ball, if you like, inside that will potentially take the hammer. Okay. Now what we can do, this is really cool, right? Now I want to do some work on that little ball to create the pendulum for the hammer option, right? How we're going to connect it, but I can't get in there to see it because it's way up inside the bell. So how can I get in there? Well, what we've got in the inspect tool, we can do what's known as a cross-sectional analysis. So we can choose the cross-sectional analysis, choose one of the faces, and it literally cuts open the object so you can see inside it. Now we can actually get to work on this section here. We could essentially drill a hole through there if we really wanted to. So that'd be a sketch operation and an extrude cut operation like we mentioned a moment ago. So that I think is pretty decent, and you can, like I say, you can choose different cross-sectional options. So if you go in our analysis in the browser view, we can edit that, and we can change the face that we want. We can change the direction. We can come in from vertical and just look down through it, that sort of stuff. It's just really useful. It's really handy. So let's say, for example, we wanted to screw something in, like we did. We want to screw the handle in, like we did with the other one. We can act with the cube where we punched the holes and drilled. We put threads in. We can actually do the opposite here, right? So if I go to the top of the bell and put a sketch in here, we'll put a center circle right bang in the center of that. And this is why it's useful to use the origin of the drawings, because they're used then as a really good reference point. So let's say we're going to put a 4mm hole, 4mm circle on here. This time we're not going to create a hole. We're actually going to create a stud. So we're going to extrude, and we're going to drag that bad boy up 7mm, and using the thread tool like we did before, we'll choose it that's fully modeled. This is now an M4 thread, right-handed, and there we have it. So you could then have an N4 hole on a wooden handle that would then screw down onto there, and you have your bell attachment. Cool. So, do you guys have any questions? Is there anything that I haven't covered? Is there anything that you're confused about that you'd like me to go back over? Is there something else that you would like me to cover? Yeah, right? It's really powerful. And I think the biggest aha moment that I had was when I realized I I need to look at objects in their three-dimensional planes and understand what a drawing of that thing would look like. And what tools do I have available to make things as simple as possible? So it's really interesting. To give an example of that, like I say, I am working on restoring a CNC machine, and the original stepper motor drivers, they had this awful arrangement where they had these plastic PCB standoffs holding 60mm fans above it. And not only was the airflow not really being effectively directed to the areas that needed cooling, it was just so flimsy, and if it took a hit, or if it if you're in there doing the maintenance, you could quite easily damage it. So I redesigned the way that those drivers were cooled. Let me open up the file here. And this is the sort of thing that you can create in here, with a 3D printer. We're going to slightly diverge off topic of Fusion 360 and look at the results of what Fusion can do. So this is one of my models. Essentially, it has a series of holes in the base that allow me to put a screwdriver through and screw down into the main PCB stands. And I have a flow, or I have the ability to direct the flow of air directly down onto the components that require it and restrict it from going out sideways. And the fans themselves are held in place through these little pins, right? And it's really, really effective. Excellent. I'm glad you're enjoying, Carol, and I'm glad you're getting value from it. Yeah, I mean, I could do a piece of produced content around that. I might well model a starship and 3D print that out. That would be kind of cool. But here is, see if I can hold this up to the camera. Have I got a secondary? I don't think I've got. No, I don't have my overhead camera set up on my YouTube's themes, but I'll need to work on that for next week. Let's go to main face cam, right? And I'll hold up. So this is the physical object that I made. This is 3D printed in PETG, and if I get in close, let me just turn autofocus off this camera, or should I say turn it off? Let me grab control of the focus of the camera, is what I meant to say. Words escape me in this moment of need. So if I bring this up to the camera, I'm hoping to be able to show you this. See if I can get it where the light catches. There you go. You've got it right there. So can you see on the vertical sections just here, you can see that there are artifacts because of the print head trying to slow down, and it's trying to change direction. Whereas if you look at the edges of the rounded corners, there are a lot less artifacts. The artifacts that are present are there due to the 3D printer changing in Z height. And you'll also notice something else here. So my 3D printer is fitted with a 0.6mm nozzle. Most 3D printers, the default is 0.4. I've upgraded to a 0.6 for the purposes of being able to print faster. Now you can go, I think it's somewhere in the region of 80% of the nozzle diameter you can go in height. So I'm with a 0.6, I can go up to, I think it's a 0.48. And that's what we're doing here. The bottom section of this unit has been 3D printed in a very coarse layer height. But then in the upper section, where the clips exist, that's actually been printed in 0.2. And the reason I've changed the resolution on the height is to make sure that the clips themselves, the overhangs are created properly and we don't get any problems. If I can try and hold that in camera shot. Come on, you noob. Oh, dear me. What can I say? So yes. So there is a 3D object that I printed. One of the other things that I 3D printed is this air raid siren behind me. This is something that I use on my Twitch stream. Somebody subs to me, or if they make a donation, or they if they buy merch from my merch store on Twitch, that bad boy goes off. And let me tell you, it's loud. Now, I am considering wiring this up for YouTube Live, so that if somebody subs during the stream, it will actually sound the siren off. So, yeah, I know. Light is failing me right now. I do need to get some. As you can see, I'm in a very constrained workspace, so lighting is a bit of a challenge for me. But yeah, working on it. So, do you guys want to hear this siren go off? Let me know in the comments. If we get enough people in the comments say that we want to hear it, I'll send it. And the joys of chat delay. Right there. And nobody answers. That's funny. We've got one. We got to get more interaction than one person, right? Okay, come on. That's more like it. Okay, so let's fire it up. So it runs on a Wemos D1 Mini Arduino. And let me just clear the chat moment. It runs off a radio-controlled LiPo battery. I do need to improve the power delivery of this. And let's. I'm gonna put my battery monitor on because I always like running my battery monitor because I don't like to over discharge these LiPo batteries at your peril. And we'll fire this bad boy up. So I do believe that I have an audio limiter on the microphone that I'm using here. But just in case, if you are using headphones, I warn you now. Yeah, be aware. Be aware, okay? Yeah, bearing in mind, it's currently 21:54 my time. Okay, so I just got to go into my control panel for the device because I've got a complicated workflow for it that hooks it into Twitch. But I should be able to fire off the siren manually. Okay, I'm going to count you down just in case you have somebody who is wearing headphones. You have an opportunity to take them off, right? Oh, let me tell you something. If I wasn't wearing these headphones, it would be actually painful to sit here with that thing going off, right? So these are actively saving my ears. So I'm going to count you down from 3 to 2 to 1 to 0 before I sound it off. But yeah, headphone users, be warned. In 3, 2, 1, sounding. Well, I clearly have more consideration for people's earbuds. All right. Guys, thank you so much. In spite of the technical oh my word. In spite of the technical issues, guys, I appreciate you guys hanging out. I hear you, CU Waffles. I hear you. So yeah, this is, as I say, this is the first in a series of live streams that I'm going to be conducting every Wednesday from 8 p.m. till 10 p.m. UK time, which is UTC +1. I hope you guys have gained some value out of this live stream for Fusion 360. I hope it helps you on your journey to making your ideal models, your dreams of making things. I hope it brings you a step closer. You guys have got to do the hard work and learn the tools and get things printed out. But if I can be a seed in that journey that sends you off on a path, that will make me extremely proud. So use the links in YouTube to get to my social feeds. Reach out to me. If you make something, I'd love to see it. Please tag me in a post on Twitter, on Instagram. You know, just show me what you've made. I will be back next week. Haven't yet decided a topic for Workshop Wednesdays. So if you want to reach out to me and give me some suggestions on something that you would like covered, that would be, you know, that would be awesome, because it means I'm delivering value to you. Either comment on this video, because it will be live as soon as the live stream is finished. But yeah, hopefully next week, no technical problems. That would suck, right? I think I might have ironed out what was causing me the problem, but we'll see. No problem. No problem, CU Waffles. Yeah. Yeah. Absolutely, buddy. You are more than welcome. You are more than welcome. Yeah, the family do want to kill me over that siren. I gotta be fair. God knows what my neighbors think. But I don't sound it off after 10. So, you know, all good. People, thank you so much for hanging out. Thank you so much for chatting. And if you've been lurking, I appreciate your company. I hope you guys have got some value out of this. Reach out to me if you've got any suggestions for the next stream. If not, I will pick the next topic. Potentially laser cutting, potentially something to do with programming. I don't know. I haven't decided yet. We'll play it by ear. Until next time, have fun, be safe, stay creative, press the right button on your stream controller to get the right message on screen, and I will catch you in the next one. Bye-bye for now. Good night.